The following is the video solution from JSDT Solutions. Question 10.1 says, the events S and T are independent. Okay, just remember what it means for events to be independent. This means that, so speaking about S and T, that the probability of S and T is equal to the probability of S multiplied by the probability of T. And then they tell us that the probability of S and T, okay, is 1/6. Great. So we have that value. And the probability of S is 3/4. And 10.1.1 wants us to calculate the probability of T. Okay. So the main goal is to find the probability of T, and this is the information they've given us. You see that in this equation, we can actually make the probability of T the subject, but then of course we would need to find the probability of S. And that's clearly where this comes in. So this information they gave, it's useful for this, the fact that they are independent. And then the probability of not S, this is what this means. This is the complement of S, meaning we're saying the probability of not S is equal to 1 minus the probability of S. Okay, we're just saying everything other than S. That is the probability of not S. So if you have these two circles and they have an intersection because we have probability of S and T, then this is S, this is T. The probability of not S would be everything excluding S. Okay, everything excluding S. That's why we say 1 minus, so the total minus S, and then that's what we're referring to. Okay, so we can see that we can actually use this information to find the probability of T. Okay, let's start off with this because it can help us find the probability of S, and then we can use it to find the probability of T in this equation. So the probability of not S is equal to 1 minus the probability of S. So the probability of not S, that value is 3/4. And this is equal to 1 minus the probability of S. And you see now that you can make this the subject. It's currently negative, just transpose it to make it positive. So the probability of S is equal to 1 minus 3/4, which is 1/4. So 1/4. And great, we have this. And then we can use this here. So we can say the probability of S and T is equal to the probability of S multiplied by the probability of T. Now we have this value. It's 1/6. So 1/6 is equal to the probability of S. We found that to be 1/4 multiplied by the probability of T. And now to solve for the probability of T, you see that we just multiply by 1/4. So you can divide both sides by 1/4 or just multiply both sides by 4, like 4/1, okay, by 4. So this means that the probability of T is finally equal to, this will give us 4/6, which is 2/3. And that is our answer. Moving on to the next question. Question 10.1.2 says, hence calculate the probability of S or T. So think about what that formula looks like. The probability of S or T is equal to the probability of S plus the probability of T minus the probability of S and T. Okay, this is the OR rule or the addition rule. So this is equal to the probability of S or T. We're just finding this. We already have the probability of S. It's 1/4. That's 1/4 plus 2/3 minus that intersection, which we already had as 1/6. So minus 1/6. And then we just have to find this. Okay, so here the common denominator is simply just 12. And then what did we multiply to that denominator to get a 4? We multiply by 3. So we're saying 1 times 3 is 3. And then here, what do we multiply? We multiply by a 4. So 2 times 4. And then minus 1 times 2, which is just minus 2. Okay, so that gives us 8 plus 3 is 11 minus 2 is 9. And then 9/12, they have a common factor of 3. So that is 3/4. And that is our answer. Moving on to the next question. Question 10.2 says, a group of 200 tourists visited the same restaurant on 2 consecutive evenings. Okay, so twice On both evenings, the tourists could choose beef or chicken for their meals. The manager observed that 35% of the tourists chose beef, okay, so they chose beef for the first evening, and then 70% of the tourists chose chicken, okay, for the second evening. And 10.2.1 wants us to draw a tree diagram to represent the different choices of main meals on the 2 evenings. Okay, so show on your diagram the probabilities associated with each branch as well as the possible outcomes of the choices. So draw the entire tree diagram. Okay, so here's what's going on. We have these 200 tourists and they go to a restaurant on 2 evenings. And the first evening they go, so the choices are beef and chicken that they can choose from, okay, for their main meal. So when we're looking at this, right, we're going to look at the probability of them choosing beef and the probability of them choosing chicken. And this is the first evening, okay? And they told us that the manager observed that 35% of the tourists chose beef on the first evening. So evening 1, here's the pick, 35% of them chose beef. So this means 35 out of 100 chose beef. And so what does that mean about those that chose chicken? It would mean that 65 out of 100 chose chicken. Okay, and then they say 70% of the tourists chose chicken on the second evening. Okay, so that was just the first evening, and now we'll look at the second evening. So we know 70% of them chose chicken. So we're going to say 70 over 100 chose chicken. And so that means what was the percentage of beef? That would be 30 over 100. Okay, same thing over here. We know that the percentage of chicken was 70 over 100, and then beef would be 30 over 100. Okay, so they also told us to display the outcomes. Okay, so write the probabilities associated with each branch and then also the possible outcomes. So let's look at the possible outcomes. So here's what could happen, okay, on these 2 evenings. On the first evening, we could have that the tourists chose beef, so beef, and then on the second evening, they chose beef. Okay, so we can look at the outcomes. We can actually just start multiplying them, I guess. They said show the probability of the outcomes. So, okay, the possible outcomes. So I might as well just say the total probability of beef and beef would be, and we'll say 35 over 100 multiplied by 30 over 100. And we'll get those values. Then the next one we'll have, the next possibility we can have is that on evening 1, they chose beef, and then on evening 2, they chose chicken. So the probability of beef and chicken is 35 over 100 multiplied by 70 over 100. Then the fourth outcome we can have is that, so you can see we're done with this branch, okay? We went beef and beef, beef and chicken, and now we're here. So chicken and beef. On the first evening, they could have chosen chicken, and then the second, they chose beef. And so that will be 65 over 100 multiplied by 30 over 100. And then the last outcome we can have is that they chose chicken, and then they chose chicken as well. So chicken on the first evening, chicken on the second evening. So that is 65 over 100 multiplied by 70 over 100. And these are the outcomes. I guess you can put these values here as well, but they're probably going to ask you questions on this too. Okay, so that is our answer. And moving on to the next question. Question 10.2.2 says, calculate the number of tourists who chose the same meal on both evenings. So the same meal, meaning on evening 1, they took one meal, and then on evening 2, they took the same meal. So that would be beef and beef. We can take beef and beef, or chicken and chicken. Okay, so you can see their values. So we can just write this down first. This is first the probability, because they want us to find the number of tourists. So the probability would be, we'll say beef, and then plus chicken and chicken. And then we'll just add those probabilities. So that is 0.105 plus 0.455. 0.105 plus 0.455. And let's see what we get. Okay, so that gives us 0.56. So this is the probability, but then they want the number of tourists. So if this is the probability that tourists will have the same meal on both evenings, then we have to look at, because remember, it's a probability, so it's over the total number of tourists that we have. Okay, so we're just saying 56% of them, okay, would have the same meal on both evenings. So to find out how many tourists are in this category, you need to find out how many tourists there are in total in the survey. So there are 200 tourists. So to find out the total number of tourists in this category, we'll say 0.56 times 200. Okay, what is 56% of 200? And you see that? That is 112 tourists. So that is our answer. And that is it for question 10.